Hello, welcome to Solving Derivatives with Paola, Diego, and Carla. Today we're going to get the derivative of the function x squared plus 1 divided by x squared minus 1, all to the cube. First of all, let's identify the rules we need to follow for this function. We're going to need to use the chain rule because the function is composed of an expression u elevated to the n power. With this rule, we get that the derivative of its n times u prime times u elevated to the n minus 1 power. But how do we get u prime? Well, since u is a division of two expressions, u and v, we'll need to use the quotient rule. The quotient rule establishes that the derivative of u divided by v should be v times u prime minus u times v prime, all of it divided by v squared. But then, how can we get the derivatives of u and v? Well, the power rule will allow us to do that. The power rule states that the derivative of a function f of x equals x to the n power is n times x elevated to n minus 1, and any constant is equal to 0.
Alright, first we need to identify the parts of our problem. The expression we need to solve can be expressed as u to the n power, and as we explained before, we'll need to use the chain rule. Therefore, we need to identify n, u prime, and u elevated to the n minus 1 power. We know that n is equal to 3, and u is x squared plus 1 all over x squared minus 1. But we are missing the derivative of u. We'll need to use the quotient rule to get the answer, and as before, we'll need to identify the components of our expression in order to follow the rule. We know that u is equal to x squared plus 1, and that v is equal to x squared minus 1. However, we are missing the derivatives of both u and v. The power rule will allow us to get them. We use the same values for u and v as with the other rule. We know that the derivative of a function x elevated to the n power is expressed as n times x to the n minus 1 power. Therefore, x squared plus 1 turns into 2x. The same happens with x squared minus 1, and the constants disappear because we also follow the constant rule, which states that the derivative of any constant is equal to 0.
Now we'll just plug in our values like so. We'll have the following expression: x squared minus 1 times 2x minus the product of x squared plus 1 times 2x all over x squared minus 1 to the second power. We rearrange our values to make our expression easier to understand. The third step we need to follow is factorization. In this expression, we'll take the 2x out of our expression and we'll multiply it by the expressions x squared minus 1 minus x squared plus 1. Next, we'll solve the parentheses. This will result in the expression 2x times negative 2 all over x squared minus 1 to the second power. Our answer is negative 4x over x squared minus 1 to the second power. This is the u prime we needed to solve our original expression. Alright, so now we'll need to use the chain rule. We plug in our values, n being 3 and u prime being negative 4x over x squared minus 1 to the second power. The value for u is our original expression raised to the n minus 1 power. Therefore, we have that u is x squared plus 1 over x squared minus 1 all raised to the second power. Now we multiply the 3 times u prime. This results in the following expression: negative 12x over x squared minus 1 raised to the second power. The other part of the expression remained unchanged, therefore we just lower it. Now we combine the terms by multiplying them, which results in negative 12x times x squared plus 1 elevated to the second power all over x squared minus 1 elevated to the fourth power. This is our final answer.